guys want to meet?
Oh, okay. I'm Laura.
I'm Kaustubh. I'm Christoph.
All right, and we're going to kind of group. That's actually a picture of our antenna on the roof, and that is our antenna that we built. So we'll start. Okay, so we built a Yagi antenna, and that one on the left is just a basic 2, 4, 6, 7 element antenna, and we built a 10 element Yagi so that it would have more power. All right. So we designed our antenna using a program called NEC. So there are like basic rules of thumb for designing a high gain antenna. And you just put things into this program, and then it optimizes the dimensions of the antenna, so like the length of the elements, so that it will have the most gain. That doesn't really show very well. Yeah. Maybe we'll turn that.
That's what I did.
But did you guys see that? Like, all of it?
Okay, well, 2 seconds. Okay. This is like tag file. Oh, I get awkward. So we were designing our antenna, and the neck file like optimized it, but we had to make it or like design it so that we would know what we're doing, and we just weren't like, hey, we kind of did this. So we used CAD to draw the antenna, and then these would be I don't know what they're called. And then we made it so that we could raise up the antenna because we were making the antenna with the intent to do a moon bounce. I guess next. So this is what our projected results, like what we should get in a perfect world. And this shows like the gain pattern. And this one shows the gain pattern, and it was really crazily forward biased. And then this one shows the SWR at the frequency that we wanted to be at was 220. So it had a really good SWR.
Building our antenna. So in our antenna back here, we have 10 elements, and each element is a dowel rod covered in aluminum foil. And so we drilled 10 holes into the boom, which is this thing, and that we used electric tape to hold in the wires or the rods. And the PVC pipe, the diameter of this one is, I think, 1.5 inches. And to hold this up, we needed a base. So you can see up ahead, we had a PVC pipe put into 2x4 boards, and those boards were drilled in with screws. And the next slide, you can see the final. So that's what our antenna looked like all together. And we found our antenna's gain pattern. We also received a signal from a ham radio operator in Bellevue, and it's pointing west towards Bellevue. So this is just on top of the Malott building. At the beginning of this project, we had one experiment where we measured the gain pattern of Steven's antenna, and his frequency was 54 megahertz. So we went out in the field and we walked around this antenna with an equal radius, and we walked around it with a transmitter, and we measured the power received by the antenna at each spot, and we figured out the gain pattern. So the green one is a theoretical gain pattern, and the red one is the one we actually got. The red one kind of looks better because it has more forward gain.
Okay, on the right is the signal from the ham radio operator. The equation on the left tells us, based off of the power of the transmitting antenna and the gains of the two antennas, the distance between them and the wavelength that we were using, it tells us how much power we should be getting, and that's the expected power. But all we know is that because our setup automatically amplifies the signal we're getting, all we know is that our actual power we receive is at most 30 decibels away from that expected value. So on the left is the next program prediction of what our gain pattern should be, the red line, and then on the right is when we actually measured it, so you can see they're fairly similar.
And so they don't look exactly the same or even that much the same, but the actual one is more realistic because of the front and back lobes, and also you can see side lobes, which happens in the real world, and for some reason doesn't happen with the expected.
Okay, so our antenna could be used in the future for executing a new bounce, which is using a different antenna to transmit a signal and bounce it off the moon and then receive it at our antenna. Eventually, we want to use the data from the moon and maybe other experiments to use antennas to collect information about meteors.
Any questions? Jordan?
Can you explain SWR figure?
Okay, so SWR stands for standing wave ratio, which is like the ratio between the amount of waves that are going into the antenna versus the amount that are coming out.
So lower is better?
Yes. Yeah.